Okay, so today this is reactions for balancing chemical equations. Last time we talked about the kitchen example. Some of you did really well with it. Some of you kind of struggled. So we're going to go through today. You're going to talk about accurately placing coefficients in chemical equations to balance the reactants and products. Some of you are looking at that thinking, I still don't know what that means. That's okay. We're going to work through it. We already went through the bell ringer. We watched this video talking about the triggers of a chemical reaction, what makes a chemical reaction go. In class, we're going to skip this video, but we're going to go on to this simulation. So it's similar to the kitchen example, but we're going to go through it today. I'm going to give you some pointers. The same as before, which has been a whole week ago, so you might not remember, but take a screenshot of your 12 stars and submit that screenshot. So let's see, what on earth am I talking about? Looking at this simulation that's embedded here, I'm going to go down to the 3 dots here, and I'm going to make it full screen so that it's easier for us to see. And then here's the introduction. So let's go through this together. All right, so if this is our chemical reaction, what is on the left side? Are these reactants or are these products? These are reactants because the reactants are what start the chemical reaction and the products are what you're making out of it. Just like if you had a business, your product is what you're creating. So we're going to start by putting one of all of these things up here. So now we have a coefficient of 1. Do you always write the coefficient when it's 1? No. The coefficient could be invisible. We have an invisible 1 a lot of times when we do that. Looking at this simulation, it looks like we're just counting like we did last time, but we do have some tools that are available to us. If we look at this upper right-hand corner, I'm going to go ahead and use some tools, okay? I like the graph because it lets me see really clearly. You can feel free to use the balance if it gives you a better visual, but I like the graph. So I can see here, I have 2 of the blue spheres for nitrogen because my subscript is 2. So coefficient times subscript, 1 times 2, gives me 2 atoms of nitrogen. So I can see that in the picture though. There's 2 atoms here. The same for hydrogen. I have 2 atoms of hydrogen. But in my product, how many atoms of nitrogen do I have in my product? Show me on your fingers what you see. There's just 1 because there's 1 on the graph it's showing you. If I take my coefficient times my subscript right here by the nitrogen, which is an invisible 1, coefficient 1 times subscript 1 gives me 1. So let's look at hydrogen. Coefficient 1 times subscript of 3, I have 3 hydrogens. But what we need to do to balance the chemical equation is we need to make these the same. Because we cannot lose atoms. Atoms can't just run away or float away or be destroyed. No matter can be created or destroyed in a chemical reaction. So over here, it looks like we have 1 more hydrogen than we started with. Well, we're not magic. We didn't just make it come out of nowhere. So we have to prove where it came from. So I'm going to go ahead and make this a 2. Now my nitrogen matches on my reactants and on my products over here. But my hydrogen doesn't match. How could I make the hydrogen in the products match the hydrogen in the reactants? Go ahead. Yeah, I could add some more. So we're going to go ahead. See, we got our smiley face on there. But we made the hydrogen atoms match. Now look what happened. Our coefficient is what changed. So we're going to multiply the coefficient 3 times the subscript 2, and we get our 6 atoms of hydrogen. Give me a thumbs up if that makes sense. Okay, cool. All right, let's separate water. So we're going to go across this blue ribbon at the bottom and go separate water. Again, I like the graph. You can pick whatever you want for your tools. I'm going to start out with my coefficient of 1. And we look and we say, okay, it doesn't match. It is not equal. On the reactant side, which is what I begin with, I have 1 times 2 for hydrogen. That gives me 2 atoms of hydrogen. There's my 2 little atoms right there. I have 1 times 1, so the coefficient of 1 times the subscript of 1 for oxygen. That gives me 1 atom of oxygen. There's my little 1 atom of oxygen. But in my products, I have 1 molecule of H2. So the coefficient of 1 times the subscript of 2, because there's 2 atoms in each molecule. So 1 times 2 is 2 for both of those. So what coefficient do I need to change? Well, I need to have 2 oxygens in my reactants because I have 2 oxygens in my product. So I'm going to increase that to 2. And look, I messed up my hydrogen. How can I fix the hydrogen in the product so that it matches the hydrogen in the reactant? Any thoughts? No thoughts? If I look right here, if I change my 2, see, now I have 4 hydrogen and 4 hydrogen. If I look at my numbers and I actually count them, I can say coefficient in the reactants is a 2, and the subscript on hydrogen is a 2. So 2 times 2 is 4 hydrogens. And I can see that in my picture. I can see that in my graph, and I can see it in the picture. 1, 2, 3, 4 hydrogens. In the product side, my coefficient of 2 times my subscript of 2, 2 times 2 is 4. I can see that in my graph, and I can see that in my picture. I have 2 molecules of hydrogen. So I have 1, 2, 3, 4 atoms of hydrogen, and it matches. All right, give me a thumbs up if that makes sense. The pictures helped. And a thumbs down if you're still lost. Okay. All right, so what you're going to do next, I'm going to let you go ahead to the game. So if you look at the black bar at the bottom, it has a little house, it has introduction, and then it has game. Here's where you need to get 12 stars. I don't care how you get 12 stars. You can get 10 and 10 and 2. You can get however it adds up to 12, but you need to have 12 stars. You're going to hit level 1 and get started. They're going to come in different orders, so I can go through a couple of them with you, but it's going to help for you to do this on your own so you can see it. So if we start with 1, we can see, now we got to count it. We don't have all of those tools like we had before. So we're going to say, okay, let's see. I have 1 atom of nitrogen because coefficient of 1 times subscript of 1 is 1, and I can see that in my picture. I have 2 atoms of oxygen, and I can do that with math by saying coefficient of 1 times subscript of 2 is 1 times 2. That gives me 2 atoms of oxygen. But it doesn't match over here. So it's a little bit harder. I realize that I can only have 2 atoms of oxygen, but I have an uneven number here. So I'm going to go ahead and increase this product. That automatically tells me, okay, I have 2 blue nitrogens here. So I need 2 blue nitrogens in my reactants. I'm going to count. Okay, so 2 blue, 2 blue. Let's do some math. 2 times 1 is 2. So that gives me 2 atoms of nitrogen. 2 times 1 is 2. That gives me 2 atoms of nitrogen in the reactants and products. So they match. And now I need to look at oxygen. So in the reactants, the beginning of the equation, I have a coefficient of 2 times the subscript of 2 on oxygen. So I have 4 atoms of oxygen. I can see that in my picture. 1, 2, 3, 4 red oxygen atoms. And in my products, I have 1, 2, 3, 4 red. And I can count that using math because my coefficient on nitric oxide is 2 times 1. That gives me 2 oxygen atoms plus 1 times 2. That gives me the other 2. So now I have 4 oxygen atoms. And I check it, and I'm happy chappy. Okay. So I'll do one more example, and then you can work on your own on those. All right, so looking at this next example, I know I have to start with something. So I'm going to start my reactants. I'm going to give me one product. I'm looking at that and I can say, well, I can see that the oxygen doesn't match because there's 2 red spheres here and there's 1 red over here. So I need to increase that. So now I have 2 oxygens because 2 times 1 is 2 oxygens. I can see that in my picture. 1 times 2 is 2 oxygens, so that matches. But my carbon doesn't match. I have 2 carbons here because I have a coefficient of 2 and a subscript of 1. So I'm going to make that increase. Okay. And I'm going to check that. Yay. All right. I'm going to go ahead and stop recording, and then I'll come and check with you guys and see if you need some help. Okay.